So what we're going to do in 2.5 is we're going to take everything that we learned, so everything was analyzing the graph, and just do it to one graph. So this is still 2.5. This is the last day. We're going to do 2.5. Okay. So we want to find the following, and we'll answer in interval notation or as ordered pairs, just depending on what we're looking for. And the first thing it wants is the domain and range. So if you can't see in the back, we have arrows here. And okay, so domain and range is bounding our entire graph. So domain, we look left to right. So is there a minimum x value for the whole function? No. No, there's this arrow here. Is there a maximum x value? No. Okay, so negative infinity to positive infinity. Range, so this is the only interval where I'm writing in terms of y, is when we do range. And we want the entire function. So if I have, say, do we have a minimum y value? Well, we do have a local minimum, but for the whole function, no, we don't. It's still an arrow here, so it's still going to go all the way to negative infinity and then all the way up to positive infinity. Okay. The zeros are where the graph crosses the x-axis, your x-intercepts. And this one here that it doesn't give us the point for, we're going to assume that that's negative 3.50. It doesn't tell us, so we just can assume, since this one's 3.5, that this can be a 0.5 as well, and that would be negative 3.5. So zeros are points, so write these as ordered pairs. Okay, I have 3 of them. Then I have intervals where the function is greater than or equal to 0, and then less than or equal to 0. So using this graph here and using my zeros, okay. So greater than or equal to 0, so x-axis is my 0, so I want this part and this part. Okay, greater than or equal to 0. Write that as an interval in terms of x. So these intervals are in terms of x. We have equal to, so I can use brackets. I'm including those points. So it would be from negative 3.5 to 0. And then 3.5 to positive infinity. Okay. Now we want less than or equal to 0. I want below the x, and it's equal to. So again, I'm including those points. So write down what you think these intervals would be. There's two different places, so two different intervals. So negative infinity to 3.5, to negative 3.5. And then from 0 to 3.5. Questions about that? So greater than or equal to 0, less than or equal to 0. Use your x-axis as 0. Greater than is above, less than is below. Since it's equal to, you include the zeros. So you use the brackets. Okay, local maximum or minimum. So we're going to go back and do D, but E will help us with D, so let's skip to E. So local maximum or minimum. So I have one of each. I have a local maximum. That's at negative 2, 3. So this is a point, write it as an ordered pair. And then a local minimum at positive 2, negative 3. Okay. So now I want to do increasing, decreasing, constant. So now I'm looking for the places on the graph, if it's increasing, where it's going up from left to right. So I know there's an arrow pointing down, but if I'm reading this left to right, it is going up. And then it looks like I go down, and then I go up here as well. So two different places where I'm increasing, so two intervals. You'll connect them with a union sign. So that's negative infinity to negative 2. Increasing, decreasing, constant, only use parentheses. Okay, and then I have from positive 2 to positive infinity. Okay, decreasing. Looks like I'm decreasing there. So one interval means, or one place on the graph means one interval. We always read it in terms of x, so we're looking at our x coordinates. So that will be negative 2 to 2. And then I'm constant, nowhere. Okay, so we took everything we did in this section and we put it in one problem here. Does everybody understand the differences of the different questions they're asking us here, the different parts? So the difference between greater than or equal to 0 and the difference between increasing, if we understand those differences. Okay, so we're going to do this again, but we're going to apply it to this graph here from this word problem. So this is the graph of this construction company. This is number 52. This is on, this is section 2.5. Okay, so we're going to go through and answer the parts of this graph. This says years since 1990 on X. This is the profit in millions on Y. We are going to say that this is an endpoint and not an arrow, so this graph is just analyzed for 10 years. Okay, so part A, what do you think this is saying? F of X with this arrow. Increasing. So that's wanting to say, when is the graph increasing? So let's go through. I see it's increasing from here to here. And then I increase again from here to here. And then I'm decreasing, decreasing, and then increasing, increasing. Okay. So first of all, I'm increasing from the interval. We're using X. So 0 to 1. This is the 0.18. I'm also increasing from here, so this is 3/8, to right here, which is 4/12. So I'm increasing from 3 to 4. And then over here, this is 7, -4. So 7, -4. And then you see that there's a little bit of a change right here. Well, I'm still increasing though. I'm just increasing at different rates. So I don't have to stop here because I'm still increasing from 7 all the way up here to 10. Okay, so I just changed the rate at which I was increasing, but I didn't stop increasing. So this is 10, 16 up here. So 7 to 10. Okay, decreasing, decreasing, and then still decreasing. So what would that interval be? 4 to 7. So even though the rate changed, you didn't stop decreasing. So it still goes 4 to 7. And then I was constant just right there. So 1 to 3. Remember, you write these in terms of X. It's really important for these that you have your element sign. Your X is an element. So we know it's an interval and not an ordered pair. Okay, so for our relative maximums, so I have this point right here. I can tell that's a relative maximum. So that's 4/12. So since this is an ordered pair, I don't have the element sign because this is an actual point. Okay, I also can say 1016 is a maximum because it's a maximum of the whole function. It's an endpoint. 1/8 is not a maximum because you do not decrease. So to be a maximum, you would have to go from increasing to decreasing.
So would you list both answers, both points as the answer?
Yes, both points as the answer. The ones on your quiz or test aren't going to be, I don't know, as difficult to figure out. It'll be pretty obvious which ones you're looking. The ones in the quiz or test look more like this type of problem here. And then I have only one minimum, one relative minimum. The reason why I wouldn't say the endpoint is a minimum because it's not the minimum of my whole function. Okay, positive and negative now. So this means greater than 0 or less than 0. So since it just says positive, we don't include 0. It just says negative, we don't include 0. If it wanted us to include 0, it would say greater than or equal to or less than or equal to. So we're going to use parentheses for all of these because we're not including the zeros. 0 is not technically negative or positive, so that's why it's not included. Okay, so positive, I want all the parts. I want all the parts that are above 0. So here's my zeros, and it asks about those two. There's the zeros. So if I want positive, I want everything above those. So x coordinates, so 0 to 6, and then 8 to 10. Let's interpret that, what that means. So I think you'll understand what the graph is saying too. So you want to know, when is our profit positive? When is our profit positive? Okay, well, from 1990 to 1996, and then again from 1998 to 2000. Okay, do we understand that part from the graph? Okay. And then where was it negative? Well, it was negative right here. So from 1996 to 1998. So where x was 6 to 8. And there are two zeros. 6, 0, and 8, 0. Those are your x-intercepts. And then finally, we'll look at domain and range. And domain and range will bound this graph. We want the entire set of x values, the entire set of y values. So this graph is just analyzing from the year 1990 to 2000. So on our graph, x is going to go from what to what? X goes from 0 to 10. Those are both points on the graph, so we have brackets. And then range is the only thing where we write in terms of y. So what's the minimum y value? -4, and the maximum? 16. Good. Questions about that? Yeah, I mean, it's not going to say, it'll tell you what parts, so it's not, you're not going to have to memorize, like, oh, I need to know the maximum, minimum, and the increasing, decreasing. It'll ask you for the parts, but yes, you'll have to know how to do all of them. I don't know that you'll do all of them, every single one, but you will do more than one on a question. Okay, so we need to talk about the difference quotient. So the difference quotient is this little formula, and you won't have to memorize the formula. It'll be given to you. You just have to know how to use it. So what it is, it's a formula to find the average rate of change. Over a specific interval, so a specific spot on your graph. So in other words, it's the slope of the secant line that goes through 2 points on your graph. Okay. So not every graph is a line, and therefore it has different rates of change. So like if you think of a quadratic, so like this one is a quadratic. So it's going to look something like that. The slope on the left is negative, it's decreasing. The slope on the right is positive, it's increasing. Also, there's parts where it might be decreasing faster or at, a steeper rate than other parts of that graph. So what this difference quotient is, it gives us a formula to find the rate of change anywhere on the graph. That's what the difference quotient does. Okay. So I'm going to plug in f of x, which is my given function. So this part goes here where the split box is. I have to calculate or evaluate f of x plus h. So I have to plug in x plus h into my function, and that goes here in this red box. So let me go ahead and do the g of x plus h. So I'm plugging x plus h into my function. So that's 4x plus 4h plus 1. No like terms, so I'm done here. Okay, so this is what goes into the red box. So let me write it out. I'm going to write this out, and then I will simplify. So 4x plus 4h plus 1 minus my given function, and I'm putting it in parentheses because I need to remember to distribute the negative. I'm subtracting that entire function, so I have to subtract every term. And then that's all over h. Okay, so simplify, And you will get this function to cancel. That's kind of the point of this. Okay, so I distribute that negative over h. Now on the top, I want to combine like terms. 4x and negative 4x is 0. 1 and negative 1 is 0. So all I'm left with is 4h over h. Which is 4. So that's my formula. That's my rate of change between any 2 points on the graph. Well, go back to your function. G of x equals 4x plus 1. This is a linear function. What's the slope? 4. Yeah, so that makes sense that I get a constant here, which is 4. So this was a long way of finding that the slope was 4.
So is that always going to match your slope?
Yes, well, but not everything is linear.
Okay, so if it's linear, it'll match the slope.
Yeah, yeah, yeah. So if it's linear, then your average rate of change is going to be your slope because it never changes. Your average rate of change will stay the same. Your slope is constant. Okay? But not everything is linear. So like I said, when I drew that little parabola, the left side has a negative slope, the right side has a positive slope. So I'm finding a formula to find the slope anywhere on the graph. Okay, so again, my given function goes in for the blue box. And then I have to evaluate x plus h. And that's what will go in the red box. So x plus h squared. So I'm putting this x plus h into x. So x plus h squared minus 5 times x plus h plus 2. So here's where knowing that binomial squared shortcut is helpful. If you need to the side, write this twice in FOIL. Okay, do that. Okay, so the shortcut is a squared. A is x, so x squared. And then it's 2ab. So x times h is xh times 2, 2xh. And then b squared, which is h squared. Okay, distribute. Minus 5x minus 5h plus 2. I don't see any like terms. Don't get caught up in the order you're putting your variables. Just multiply it out and then stick it in the formula. Okay. So this is going to go in for the red. And then I want to subtract the blue. And then that's all over h. So distribute your negative and then combine your like terms. And you will get things that will cancel. So distribute the negative. So what should cancel are all the things that don't have an h. Okay, so my x squared, negative 5x and positive 5x, 2 and negative 2. So I'm left with 2xh plus h squared minus 5h all over h. So my goal is to then be able to factor out an h and cancel with the denominator. Okay, everything has an h, so I can factor out an h. Again, I don't really care about the order that you leave your answer. So I factored out an h and canceled it with the bottom. So I get 2x plus h minus 5. So I'll talk about what that means, but first, does everybody understand the algebra? Everybody okay with the calculation part here? Okay, multiplying it out, combining our like terms. They see where we plugged in for formula here, how we plugged it in. Okay, so what this tells me, so this is my answer. Notice that it's not a constant because the rate of change is not always the same. It's always the same if you have a line. But if you have any type of curve, okay, then it's not always going to be the same. So we can plug in numbers 4x and h and calculate the slope on a given interval. So if I said, what is the rate of change from -2 to 6? So if I wanted to know what's the rate of change from -2 to 6, I could plug numbers in here. So I don't know exactly what this graph looks like, but let's say it's something like this. And I'm wanting to calculate from -2 to 6, what is that rate of change on the graph? So I'm wanting to know, okay, let's say here. So this is going to give me that slope. That's here. This is obviously not drawn to scale. This isn't the correct graph, but this is just giving you an idea of what it is that we found. So when I plug it in, this is my x, and then h is the distance between these 2 points. So from -2 to 6, we went 8 units. From -2 to 6, you went 8 units. So using my formula, I can plug -2 in for x, 8 in for h, and so that's -4, -1. Obviously, my graph is not drawn right because that looks positive, but I just sketched a graph there. So the slope from those 2 points on our graph would be -1. This is a formula that could find rate of change anywhere. You just would have to tell me where to look. And let's say we're going to look here. I could have picked anything for this interval, though. Okay, so we'll stop there.